Hi everyone, today we're going to study how to solve congruence equations. Let us define congruence equations. For relatively prime moduli m and n, the congruence is x is congruent to a mod m and x is congruent to b mod n. Have a unique solution x modulo m times n. In this video, we are going to see two methods in solving congruence equations. These are, letter A, trial and error method. Second method is simultaneous equations method. Example 1. Find the value of x such that x is congruent to 2 mod 3 and x is congruent to 3 mod 5. In this example, we're going to use trial and error method. First, we're going to note that the moduli 3 and 5 are relatively prime. For step 1, in the first congruence, x is congruent to 2 mod 3. We say that the value of x is equal to 2 plus 3k, for some k, an element of z, meaning k is an integer. We can write the values, so we start with 2, 5, 8, 11, 14, 17, and so on. Now for step 2, let us consider the second congruence. X is congruent to 3 mod 5. And we say that the value of x equals 3 plus 5d, for some d, an element of z. Now this is what we're going to do. We're going to scan the sequence from step 1, meaning all these numbers, for a term that leaves remainder 3 after division by 5. So we start with the first term 2. 2 divided by 5 is 0 and the remainder is 2. It means this number 2 is not our x. Let's go to the next term 5. 5 divided by 5 is 1 and the remainder is 0. Thus, this 5 is not what we want. Let's go to the third term, 8. 8 divided by 5 is 1 and the remainder is 3. So, this is our x. So we write here x equals 8. If you want to check if our answer is correct, let us substitute this 8 in the congruencies. So 8 divided by 3, the remainder is 2. Thus, x satisfies the first congruence. For the second congruence, 8 divided by 5, the remainder is 3. It is also satisfied. X is equal to 8 is the final answer. Example 2. Find the value of x that satisfies x is congruent to 1 mod 5 and x is congruent to 4 mod 7. This time, we're going to use simultaneous equations method. First, we're going to know that the moduli 5 and 7 are relatively prime. Then for step 1, we will copy again the congruencies down here. In the first congruence, we say that x is equal to 1 plus 5k, for some k, an element of z. For the second congruence, we have x equals 4 plus 7c, for some c, an element of z. Now for step 2, we're going to equate the values of x. It means 1 plus 5k is equal to 4 plus 7c. From here, let us solve for k. This constant one, we're going to transpose on the other side. That becomes 4 minus 1. It becomes 3. So we write here 5k equals 3 plus 7c. Then we divide this equation by the coefficient of k, which is 5. So the value of k equals 3 plus 7c all over 5. From the beginning, we put that k must be an integer. So we write here, since k is an integer, we need the numerator, this 3 plus 7c, to be a multiple of 5. We can think of any integer to make this numerator a multiple of 5. So we say that c equals 1. We substitute 1 in the c here, so we have 3 plus 7 times 1 all over 5. 7 times 1 is 7, 7 plus 3 is 10, and 10 over 5 is an integer, which is 2. So we go to step 3. We substitute the values of k and c to equations in step 1. So the x is equal to 1 plus 5k, it becomes 1 plus 5 times 2. For the second equation, it becomes x is equal to 4 plus 7 times 1. When we simplify both equations, we will get the value 11. Thus, x is equal to 11. This is the final answer. I hope you learned something from this video. See you again next time.